Next presentation, 21st Century Steam Reforming Catalyst Technology by Mr. Himanshu Chauhan. So Himanshu Chauhan looks after the business development activities across the Asia Pacific region at Unicat Catalyst Technologies. After completing his chemical engineering in 2007, he has worked with Hewlett Topsoe, Johnson Matthey, etc. He has over 15 years of technical sales and business development experience. He is a graduate from BITS Pilani and a master's from UPES. Over to you, Himanshu.
Chairman, Mr. Bharatan, for the kind introduction. On behalf of Magma Unicat Group, first of all, very sincere thanks to organizing committee at GRPC for giving us this wonderful opportunity to present on this, this topic, which has always been very close to my heart, having spent around 15 years in the catalysis industry, majorly around hydrogen, ammonia, and methanol. Well, before I justify the 21st century steam reforming catalyst technology, I think I need to answer Mr. Bharatan's question, which is an excellent question he raised while starting the session. How do we sell reforming catalyst for a gray hydrogen plant, in a gray hydrogen plant, when everyone is talking about just green hydrogen? I think that's a very, very challenging question, which we have been looking at ourselves, Magma, Unicat as well, and probably the other leading catalyst technology companies as well. And when we look at, we of course have been attending other conferences as well. And while attending this conference, the first session so far, we have already got the positive views that green hydrogen, it's a long-term solution. Green hydrogen is going to be there for minimum 20, 30 more years. That's how we are also playing around on innovating the steam reforming catalyst technology. So with this, I just start my presentation. I'll go a bit very fast in terms of the Magma group, Unicat group introduction. But since we are new to the market, so I think it would be good if I just spend only 1 minute. So Magma has been there since 2010. It has been a ceramic company, and then it has entered into catalyst because they had the expertise of making a very special carrier, which we'll talk about. We'll show it to you, like the golf ball texturing. And if you have paid attention to the very first presentation by Accents, they talked about the difference in the surface area between a golf ball and the ball without any texturing. There was a lot of surface area loss. So that's how we are also doing, and we have already made it. This is a company from Britain. We are making this product, which we are presenting. We have put our stall as well, and we would welcome you all to visit our stall in terms of getting the practical feeling of how the product is all about. It's being made in Britain. In terms of the growth of the company in 2010, it was just 24 employees, and now it has grown to 300 employees. We were merged with bigger group Unicat in April 2021 and has been the recipient of Queen's Award very recently. This is the key task force. We are being headed by Mr. Marcus Turkey, who's a British gentleman, and he's the one who invented this carrier, this looks like a golf ball, with the texturing that gives it the next level of surface area, and that's how we are bragging about in terms of the the higher activity, higher heat transfer coefficient, and the other lower pressure drop characteristics. We also have the pleasure of being having Mr. Gary Bennington, who has come here from Australia, and he's with us. So we would invite you all to visit our stall again. It's just right across the corner, and then we can have more discussion. When we talk about the catalyst manufacturing, whether it is with any leading catalyst provider, they have been majorly making it from the conventional casting process, which is the compression casting. So they have been making it, probably it is much easier, much less cost friendly as well. So there have hardly been any improvement in terms of this making the catalyst along with this technology in terms of making various shapes or something very innovative. So it leads to the cylinders, which you all might have come across in a reforming plant. So it started with cylinders, then cylinder with 4 holes, cylinder with 8 holes, and then some surface, some different surface in order to provide more geometric surface area. But this has been it. In last 50, 60 years, that has been the only improvement that we have seen. How we are different in terms of the manufacturing technology itself, apart from the various benefits that MagCat delivers, the technology of making catalyst itself is very different. If you look at, it is being made through gel casting process, where you have a polymer gelling agent, which you mix it, and that gives it a flexibility to produce various type of shapes that we can produce. So it's all about making much more robust or much more flexible carrier, and then impregnating it with the active material. So this sort of facility provides us the, it can give us the product in spheres. It can also give us the product in some of the 3D shapes as well, if it is found to be very practical. So we can make that as well. So we have molds and this polymer gelling that makes us a bit different. It's proprietary as well to some extent. The major benefit that we are getting from this gel casting is you can make a sphere, and it looks like a golf ball. It is indeed. And we have already seen in terms of the surface area, so I don't need to talk about much on that. Surface area, higher the surface area, higher is the activity for the reforming catalyst, especially in the top zone of the reformer tube. Of course, it matters in the bottom as well, the higher surface area. In terms of the sphere without any holes, but with just the external texturing, it also leads to lower drag. And that's very important in terms of the pressure drop characteristic, which is also one of the major area when we look at steam reforming catalysts. There are three. One is the activity, second is the heat transfer, and then is the pressure drop. And that's more important, probably not that important for hydrogen plant, but certainly for ammonia plant when you need to compress the gas to 200 kg or maybe 150 kg. So this is how it's being produced. It is being produced in Dewsbury. It's a bit far from Leeds in UK. This is how the mold looks like. And onto your right, there is a kiln where we are calcining the catalyst. So we are calcining it at much higher temperature, around 1500 degrees Celsius or so, as compared to the other conventional manufacturing process. They calcine it at lower temperature. So it leads to much better product in terms of the mechanical strength as well. So that's also one of the key difference. I think we talked about this. When you look at the steam reforming catalyst technology, there are always three major areas. One would be the higher activity. What does it mean for the current plant is you would be able to process more feed without breaching the process constraints. Let it be pressure drop, let it be higher tube wall temperature, let it be the higher flue gas temperature. And that is something, flue gas temperature is something which is linked with the better heat transfer characteristic of this golf ball. And you would get the feeling once you visit our stall. We have the videos how exactly it leads to higher heat transfer as compared to the cylinder with holes. Let's talk about how it has really created the value addition for our clients. I think this is very important rather than just talking about what it is there on the paper. So this is the real data from our hydrogen client from Korea. And if you look at the pressure drop benefit is 0.42 bar. And they must have some compression out after this for whatever purpose it was being used. So they are simply attributing this to the savings in terms of the compression cost. Let's look at one of the American refiner. They opted with MagCat series of reforming catalysts, and then they could achieve higher throughput, which they were not able to do with the previous generation catalysts. And this is not our data. This is the data which has simply come from the American refiner, where majority of our catalysts had been sold so far, majorly in America, around more than 15 references, mainly hydrogen plants. This is again, but this is not something which is from the plant. This is on the paper. We have the kinetic modeling capability with all the carbon formation model software as well. We can do, and this is what it talks about with the 15% increase throughput without breaching the process constraints. It is possible to achieve around the same pressure drop. If you look at the last column, 30 psi pressure drop, even at higher rate as compared to 33.4 with the competition catalyst at the base case. So let me also take you through a bit more on the 6 benefits that MagCat offers as compared to the conventional catalysts, starting with the massive surface area increase, which we have already talked about, the golf ball. So higher the surface area, higher the activity. So probably if you are looking for more hydrogen from the same hydrogen plant, we can help. How much we can help, that would depend on the detailed evaluation. If you're just looking for 5 to 10% more, simply replacing the conventional catalyst with MagCat, it is possible. That is how it has been done in US refiners as well. If, let's say, you say that you want your process to be more efficient or some less CO2, so that's something as well which we can help, because our catalyst is having higher heat transfer coefficient. So for getting the same exit temperature, you need to fire a bit less. When you fire a bit less, it leads to lower CO2 reduction. So that's something, that's also the value. Apart from the fuel value, when you fire less fuel, then it's simply the profit. This is the pressure drop benefit because of the lower drag of this golf ball. So it has been very interesting. Sometime my colleague has been talking to someone in US, and they understand more when we talk about the Tiger Woods experience. If you play with the smooth ball, it will not go very far. If you play with the golf ball, which is with the external texturing, that gives it a lower drag, and then it goes long way. So this is the thing, but this is true actually. So due to the lower drag, it leads to lower pressure drop. And that's how it is making it more attractive to, especially to those plants which are looking for these kind of benefits. In terms of the uniform packing, if you visit our stall, we have brought 4 inches glass vase, and you could see it yourself how uniform it packs as compared to the cylindrical shapes. We also have videos over there, and this will give you a practical feeling why it is leading to, sphere is the way to go. A sphere leads to uniform packing, and then it has direct impact on the heat transfer capability. This has been a problem, lower potassium falling. Probably Mr. Sarkar is sitting over here. We have had a lot of discussion during my stint with previous company. So this is also the problem with the typical hydrogen plant with the higher alkali catalyst. And at the moment, of course, you might not need naphtha reforming catalyst. You are pre-reformer in the hydrogen plant. But if you are still facing the alkali leaching, and it is leading to problem in the base state boiler, we have a solution. We have locked the potash in such a manner, it doesn't come out. Because the way it has been locked right at the polymer gelling when we are doing the gelling, and then we are calcining it at much higher temperature, 1500, so it doesn't come out. If you look at the thermal cycling in SMR tubes, which leads to, it is due to the thermal cycling which leads to higher pressure drop over number of years. Because of contraction and expansion, the forces are very high as compared to in the normal running. So this is with the standard catalyst, it really settles down. If you look at the MagCat, due to the uniform packing, it doesn't settle that much. So that's another benefit in terms of the MagCat. Again, we have the videos which are running right across in the LCD, and you would be able to see it yourself. Porosity is, of course, very important. So if we talk about the lab data, the porosity number for magma sample for reformer catalyst is 0.28 versus 0.12. And porosity is important, especially in the top portion of the tube, where the volumetric flow is still less and reactants really need to get inside to the right place where the active nickel is there. So the higher the porosity, higher would be the ease at which the reactants would be able to penetrate into where exactly they are needed to be in terms of doing the reaction with the nickel. Of course, we have got the references. Without references to talk about something in India, it probably doesn't make sense. It is still a very conservative market in terms of trying something very, very new, which is very, very new in terms of the very first time, probably. That's my experience. So we have got the experience now. We have got the references, around more than 20 references in hydrogen plants with more than 200 tube reformer as well. And we are now also opening up ourselves to our Indian clients if they do see the value, especially in terms of the value addition, if they are looking for more hydrogen from the same asset, then probably we could help. That's all. I think I probably didn't take much time. Thanks a lot for giving me this opportunity to Magma. Thank you.
I think we had three very good relevant presentations, which is relevant to each one of our refineries, starting with Accents, who covered the CCR, Grace, who covered about the FCC catalyst, and Mr. Himanshu Chauhan, who talked about the latest steam reforming catalyst. Whatever I started in the opening remark, several decades to come, definitely this hydrogen plant is required. We are aware of that. And any improvement in this steam reforming will definitely be welcome to all of us. With this, I will end this session. Thank you very much for listening to this, all the presentation. Let us give a round of applause for all the three speakers. Thank you.